In this lesson, we're going to cover trigonometric integrals. So here we have the strategy for evaluating an integral where you have sine to a power times cosine to a different power. When the power of sine or cosine is odd, we're going to use this technique right here. So here you have your Pythagorean trig identity, sine squared plus cosine squared equals 1. If specifically the power of cosine is odd, then we have sine and cosine, where cosine's power is odd. And what we're going to do is we're going to take one of these cosines and we're going to set it aside. Then we'll rewrite this as cosine squared to a power. Again, this has to be equivalent to whatever the original cosine power was. At this point, if you look at the Pythagorean identity and you isolate cosine squared, you'll get 1 minus sine squared. So that's why you replace this with 1 minus sine squared. And then at this point, you're going to let u equal sine, and then it will work out where this is the rigged part of the problem, and this will cancel out, and then you can manipulate this and then integrate. If the power of sine is odd, you're going to do a similar process, except sine will be odd, so you set aside 1 sine. You'll rewrite this as sine squared to a power, replace sine squared this time with 1 minus cosine squared, and then you let u equal cosine. The derivative is going to be negative sine, and they'll cancel with this rigged part of the problem, and then you plug in u, manipulate, and then integrate. So this example says to evaluate the integral of sine cubed of x dx. So the first step is we're going to break this down where we set aside sine of x, and then that would leave sine squared. Using the trig identity, sine squared plus cosine squared equals 1. If we solve for sine squared, you get 1 minus cosine squared. So we're going to take this and plug it in right here. So at this point, we're going to let u equal cosine. So next, we're going to take the derivative with respect to x. So we get du dx equals negative sine of x. So we get dx is equal to du over negative sine of x. So now we're going to plug this in over here. So we get 1 minus u squared. We're going to leave this sign because it's the rigged part of the problem. And dx is equal to du over negative sine of x. So it worked out great. The rigged part of the problem will cancel with this sign. I'm going to bring this negative to the front, and now we're ready to integrate. So I drop the negative down. The integral of 1 is u. The integral of negative u squared is negative 1/3 u to the third. And then I added c. And finally, we're going to plug u back in. So we're going to take cosine and plug it in here and here. And in the same step, I'm also going to distribute this negative. And just a reminder, when you plug the cosine in right here for u, it's cosine of x, quantity cubed, but you can rewrite that as cosine cubed of x. So here's our final answer. For this example, we have the integral of sine to the 6th power of x times cosine to the 3rd power of x dx. So again, we're looking to see which trig function has an odd power, so we're looking at cosine. Since cosine has the odd power, we're going to break this down and leave 1 cosine on the side. So that means we have cosine squared times cosine. So now if you look at this guy is going to be the rigged part of the problem. So when we let u equal something, when we take the derivative, we want it to be cosine so that this cosine will cancel. So that means we're going to let u equal sine. So I'm going to write that down just so we don't forget. But when we look back over here, this is fine because we're going to plug in u for sine, and we'll get u to the 6th. But this guy right here is right now causing a problem. So I want to go back to this identity up here. We have sine squared plus cosine squared equals 1. So that means cosine squared equals 1 minus sine squared. So we're going to plug this in right here for cosine squared. Okay, perfect. So now this is all sine, and then we have this 1 cosine because it's the rigged part of the problem. So we're ready to take the derivative over here. So when we take the derivative, we get du dx equals cosine of x. And then we rewrite it as dx equals du over cosine of x. So now we're ready to plug all of this in over here. Remember, leave this cosine because it's the rigged part of the problem. And dx is equal to du over cosine. So now we can cancel these cosines. And before we can integrate, we need to distribute this u to the 6th. So now we're ready to integrate. And our last step, we're going to plug u back in. So we're going to take this sign and plug it back in for u. And so here's our final answer. Next, we're going to look at a strategy for evaluating an integral where we have tangent to a power times secant to a power. First, we have when the power of secant is even. So to do so, we're going to use the Pythagorean identity, secant squared equals 1 plus tangent squared. So if our power of secant is even, we'll have tangent to a power and then secant to an even power. And what we'll do is we'll set aside secant squared this time. And then right here is going to be whatever is left to make this equivalent to the original secant. At this point, we plug in 1 plus tangent squared in for that secant squared. And then what we end up doing is we end up letting u equal tangent because the derivative of tangent is secant squared. So this will be the rigged part of the problem, and that part will cancel out when we take the derivative over on the right. And after that, we'll have plugged in u for tangent, and we'll manipulate and then integrate. So this example says to evaluate the integral of secant to the 6th power of x. So we're going to break this down and set aside secant squared. So by setting aside secant squared, that's going to leave secant to the 4th. Since we needed secant squared right here, that means this would be a 2, because when you have powers to powers, you multiply to give you the original power. And again, we have secant squared equals 1 plus tangent squared. So right here, we're going to replace this with 1 plus tangent squared. And again, leave this one here because that's the rigged part of the problem. All right, so at this point, remember this is the rigged part of the problem, so that means we're going to let u equal tangent because the derivative of tangent is secant squared, so that will cancel with this secant squared. So again, we're going to let u equal tangent, and the derivative is secant squared, and then we rewrite this as dx equals du over secant squared, and now we're going to plug all of this in over here. Again, we're plugging u in for tangent, so we write 1 plus u squared, quantity squared. We leave this secant squared here because that's the rigged part, and then for dx, we plug in du over secant squared. So at this point, the secant squareds cancel, and then before we can integrate, we want to multiply this out. So this is 1 plus u squared quantity squared. So if we rewrite this, it would be 1 plus u squared times 1 plus u squared, and then we're going to FOIL that. So when you FOIL this out, you get 1 plus 2u squared plus u to the 4th. So now we're ready to integrate. So when we integrate, we get u plus 2/3 u to the 3rd plus 1/5 u to the 5th plus c. And our last step is we're going to plug u back in. So we're going to take this tangent and plug it back in for u, and then we're done. So here is our final answer. For this example, we have a definite integral, so the integral goes from 0 to pi over 4 of secant to the 4th theta tangent to the 4th theta d theta. Just like the previous problem, because secant has an even power, we're going to set aside secant squared over here to be the rigged part of this problem. So by setting aside secant squared over here, that leaves another secant squared here. All right, so we took this secant to the 4th and pulled secant squared to the side, and that leaves another secant squared here, and then I just dropped down this tangent to the 4th here. At this point, remember, this is going to be the rigged part of the problem, so we want to let u equal tangent because the derivative of tangent is secant squared, so that will cancel out with this rigged part. That means we don't want this to be here, we want it to be with respect to tangent, so we're going to use that Pythagorean identity. So instead of secant squared, we replace it with 1 plus tangent squared. And then we drop down this tangent to the 4th, and then also drop down the secant squared d theta. So we let u equal tangent. Now we're going to take the derivative. So we get du d theta equals secant squared theta. And next we're going to convert our limits. So we're going to plug pi over 4 in right here for theta, and then we're going to plug in 0 for theta. So again, we're plugging in pi over 4, so we get tangent of pi over 4, and that equals 1. And then we're plugging in our lower limit, and tangent of 0 is equal to 0. And now we're ready to plug everything in over here. So I plugged in u for tangent. I left the secant squared because that's the rigged part of the problem. And then d theta is equal to du over secant squared, so I put that right here. All right, at this point, these secant squareds cancel. And before we can integrate, I'm going to distribute this u to the 4th into the parentheses. Okay, and now we're ready to integrate. And since we converted our limits, we're going to plug 1 right in for u, and then subtract plugging in 0 for u. So when you plug in 1 for u, you get 1/5 plus 1/7, and then you subtract plugging in 0, but when you plug in 0, you just get 0. So our final answer is 12 over 35. Next, we're going to look at evaluating an integral where you have tangent to a power times secant to a power, but this time the power of tangent is going to be odd. So we're going to use the same Pythagorean trig identity, secant squared equals 1 plus tangent squared, but we'll isolate tangent squared, so we get tangent squared equals secant squared minus 1. And again, the power of tangent will be odd, so we'll take this tangent to a power and we'll set aside just one tangent, and then we'll also set aside one secant. And then we'll have tangent squared to whatever power we need to make this equivalent to that. And in place of tangent squared, we'll plug in this secant squared minus 1. And then what will end up happening is we'll let u equal secant because the derivative of secant is secant tangent. So that will cancel with this rigged part of the problem. And then we'll plug in u for secant, and then we'll manipulate and integrate. So here we have the example. It says the integral of tangent to the 5th power times secant to the 3rd power. Since we have tangent to an odd power, we're going to take one tangent and set it aside, and we're going to take one secant and set it aside. And by doing that, we're left with tangent to the 4th and secant squared. So again, this is the rigged part of the problem, so we are going to leave this here. That means we're going to let u equal secant. So I'm going to write that down just so we don't forget. So this guy's good because we're going to plug in u here, but we need to work on this. So over here we want tangent squared to a power. So to make it equivalent, that means we're going to have a power of 2 up here, so tangent squared squared gives you that tangent to the 4th. And then next, for this tangent squared, we're using this Pythagorean identity. Secant squared equals 1 plus tangent squared, where we isolate the tangent squared so we get secant squared minus 1. So this is what we're going to plug in right here for tangent squared. All right, so we have secant squared minus 1, quantity squared. We have this secant squared, and then this is our rigged part of the problem, so we just have that hanging out right there. So let's go ahead over here, take the derivative. Again, the derivative of secant is secant tangent, and then we're going to cross multiply, bring the dx up, and move this secant tangent down. So now we're ready to plug all of this in over here. Okay, let's make sure I did this right. We have u equals secant, so I plugged in u, so we have u squared minus 1 quantity squared. Right here we plug in u, so we have u squared. We leave the secant tangent here, and then instead of dx, we have du over secant tangent. Perfect. Okay, so now these are going to cancel. And before we can integrate, we have a couple things we need to do. First, we're going to FOIL this out. So u squared minus 1 times itself gives us u to the 4th minus 2u squared plus 1. Then we still have this u squared, so I dropped that down. And now we're going to take this u squared and we're going to distribute it in. All right, so now we're ready to integrate. So when we integrate, you get 1/7 u to the 7 minus 2/5 u to the 5th plus 1/3 u to the 3rd plus c. And finally, we're just going to plug u back in. So we're going to take this secant and we're going to plug it in for all the u's. So here's our final answer. All right, guys, thanks for watching.